formula for the elasticity of the demand as E equals negative 1 over X times the dx divided by d prime of the x, where x is the number of the items sold and dx is the demand or the price per item function. In the case that x is given as the function of the price, where price is the demand function, we have the alternative formula of the elasticity of the demand as E equals negative P, which is the price, times the F prime of the P divided by F at P, where the P is the price and F of P is the number of the items sold. This example, a grocery store determines that the demand function for its bakery bread is x equals 180 minus 30p, where x is the number of loaves of bread it sells daily and p is the unit price. Part A, find the quantity demanded when the price is $1.70. So we're gonna find the x. And part B, find the function describe the elasticity as a function of p. Part C, find the elasticity at P equals $1.70. Interpret the result elasticity. Part D, determine the revenue function R and find P so that the R is a maximum. So for part A, we find the quantity, which is the X, when the price is $1.70. From the demand function as x equals 180 minus 30p and compute p equals $1.70, we get x equals 180 minus 30 times 1.70, which gives us x equals 129. So 129 quantity demanded when the price is $1.70 per item or per loaf. And then part B, we're going to find a function describing the elasticity as a function of the P using the formula E equals negative P times the F prime of the P divided by the F at P. From given equation, which is the X equals 180 minus 30P, this is the function F of the P. So the F prime of the P equals negative 30. Use Fp and F prime P into the expression for the E. We get negative P times negative 30 on the top divided by the quantity 180 minus 30P for the bottom expression. Simplify the expression to get 30p as a numerator divided by 180 minus 30p. As we notice that the denominator can be factored 30 out to get 30 times 6 minus p. 30 and 30 reduce. Therefore, the expression for the E or the elasticity of demand function in terms of P will be in the form of P divided by 6 minus P. The next part, part C, we're going to find the elasticity at P equals 1.70. So part C, the E at P equals 1.70 is 1.70 divided by 6 minus 1.70. And then the number can be simplified to be 51 over 129, which is 17 over 43 as a simplified number. And we see the number is less than 1. That means the demand is inelastic. We say that the demand is inelastic. And what does it mean? It means that an increase in price will bring a decrease in revenue. And then the last part of the problem, we're going to find the revenue R or the function for the revenue and find P so that R is maximum. And we find the P. For the revenue Rx, it is X multiplied by P. And the X is given to be 180 minus 30 times P multiplied by P. This part provided by the problem. Then simplify the Rx to be 180P minus 30 times P squared. And this time we just rewrite it as R as a function of the P because it depends on the price instead of the item sold. And next, we're going to find P when the Rx is maximum. You can use the straightforward way by finding the critical number and let it be 0. Or I'm going to put it, this is the option 1. Or the option 2, we're going to use the relationship that at the unit elasticity or the E equals 1 will give the maximum revenue. So let's start with the option 1. So we find the R prime to get 180 minus 60 times P and let it be 0. We get P equals 180 divided by 60 or 3. That means the price per item will be $3 per loaf. That will give you the maximum revenue. You can verify by using the second derivative test as R double prime equals negative 60, which is less than 0. Less than 0, the graph concave down will reach the maximum price. For the second option, if you use elasticity equals 1 or the unit elasticity, from the formula that we obtained in part B, the elasticity is E equals P divided by 6 minus P. And let it be 1. So 1 equals P divided by 6 minus P. Solve for P. Cross multiply. So we get 6 minus P times 1, or 6 minus P equals P. So 6 equals 2P, or P equals 3. The same result as what we did with the traditional way by finding the critical number. And that critical number will give either local max or local min. For this case, we'll give the maximum value of the revenue.